Good day, everyone. We are now getting into more complicated problems that need integration by parts for maths 6. So we still have our formula for integration by part. That is on page 4 of the maths 6 formula sheet, and the elect abbreviation to help us make our selection. So once you see problems like this that involves arctan or inverse check functions, see generally all inverse check functions, arcsine, arccos, arccot, arctan, we use integration by part. But considering the fact that integration by part needs a product, each time we see a function that is standing alone, the first thing is to make it a product so that it can be able to accommodate integration by part. So if I'm making arctan a product without really changing the problem, the only way I can make it a product is to call it 1 times arctan 4x. So you see it's still arctan 4x, but it's now a product so that it should accommodate the formula. And now we see 1 is a constant, but to make sure that it fits into this abbreviation, then we have to consider 1 as x to the power 0. And x to the power 0 means it falls under algebra. Because you see with algebra, x is at the base, a number at the top. So in that way, we will now be saying this is our algebra. And arctan falls under inverse. So this is our inverse. So looking at elect, it's therefore clear that this time algebra is involved, but inverse comes first. So that is immediately telling you there is no possibility of using the table method. As I explained in the previous videos, you only use the table method if you look at your elect and you see that algebra comes first. That means you use it when it's algebra and trig or algebra and exponential. But now that it's algebra and inverse, you see inverse comes first, so we cannot use the table method. So if you are now matching your problem to the formula, it means your f, which comes first in the formula, must be equal to inverse. So I will say let f of x be equal to arctan 4x. Since in elect I is coming first, then I will need its derivative. So its derivative needs to go there. So this one you need to go to page 3 of the maths 6 formula sheet to see the derivative of arctan. So if I'm interpreting from page 3 very well, the derivative of arctan 4x is written as the f prime, which means I differentiate that, it will give me a 4. Then at the denominator, I'll put my 4x all that square. That gives me 16x squared plus 1. So that's the derivative of arctan 4x. Because if you understand what the formula should be saying, it says when I integrate arctan of f of x, I'll get f prime of x divided by f of x, all that square plus 1. Where in this position, where you see 4x, that is what we call your f of x. If I differentiate 4x, it means I'm differentiating that, it gives me 4. Then down there, I put my f of x, which is the whole of 4x, all that square. If you square 4, it gives you 16, you square x, get x squared, then plus 1. So that's your derivative. Then, if we move on, then our g prime is supposed to be 1. That therefore means that g, if I integrate 1, I get x. I can now substitute into my formula. So that therefore means the integral of arctan 4x dx is equal to fg. I need my fg. My f is arctan, my g is x. So if I multiply these two, I will get x arctan 4x, then minus the integral of f prime g. You see the formula means f prime g. So where is my f prime? I see it there, and this is my g. So if I were to take time and multiply out my f prime g, you see I will be multiplying 4 on 16x squared plus 1 by g. Since my f prime is a fraction, if I try to write my g as a fraction, fraction also, it will be x on 1. So this is my f prime g. And since with integration I practice taking out constant, if you look at this product, you see a constant is 4 on 1. So 4 on 1 is 4, then I will be left with x over this one. So this is x on 16x squared plus 1 dx. So that's how my integral should look like. So this integral now takes us to a fraction. But if you look at this fraction very well, you realize that if you differentiate x squared, it will create x. So that immediately tells me that this is U substitution. So I'll explain the U substitution to you. Then after, I'll show you the formula on page 4 of the mathematics formula sheet that can help you do that also. So my U substitution, my U will be the whole of the denominator. Then I do my derivative. So in this case, I will say let U be equal to 16x squared plus 1. This will therefore tell me that du on dx is equal to 32x. And if you combine this, you want to make dx the subject. Usually, I say to make dx the subject, this dx and the item on the right just swap positions, the interchange positions. If that happens, it means I will say dx will be equal to du on 32x. So I'm going to substitute into my problem. So if I get back to my integral, I'll get in the integral of arc tan 4x dx being equal to x arc tan 4x, then minus 4. Then in this integral, I'm replacing my 16x squared plus 1 by u. Then I replace dx by du on 32. That is du on 32x. In that case, you see that x will take care of x. 32 and the denominator will go out as 1 over 32. So I'm simply getting x tan 4x minus, if 32 goes out, I'll be left with 4 over 32. Out there, the integral of 1 over u du, and the integral of 1 over u is going to give me lim, as we already know. So this can be written as 1 over 8, that is 4 and 32, or still 4 and 32. Then this will be lim u plus c. Then I have to replace u by the value of u, which was 16x squared plus 1. So that should take me to x tan 4x minus 1 and 8, the lim of 16x squared plus 1 plus c. So this is simply how we integrate this using integration by part. So method 2 is simply exploiting a formula that we will use for integration by part. So with method 2, I will just copy everything the way it is until when I reach here, in the place of integration by part, I will show you a simple formula from page 4 of your formula sheet. So with method number 2, I'm integrating arc tan 4x. So I'll just copy from there. I'll say let my f of x be arc tan 4x as we've done before. Its derivative will be 4 on 16x squared plus 1. And if we get g prime of x giving us 1, then g of x will be equal to x. So I'm copying fast because it's the same thing up to that level. Then therefore the integral of arc tan 4x dx will be x arc tan 4x minus 4, the integral of x on 16x squared plus 1 dx. So you see that this side I took time to go through u substitution. So in maths N6 there is an easy formula for that, which you don't need to waste your energy too much. If you are doing your integral, you discover that you've got a fraction which is in such a way that you can differentiate the variable here. You see, I don't bother myself much about 16 and 1. If I can differentiate the variable that it creates that one there, then this is the formula for u substitution for fractions. It's there on page 4 of Math N6 formula sheet. So students who practice how to navigate themselves through this formula, they will not have so much of a problem doing all these long calculations we've done there. So this is how we do it. Once I can discover that the variable here, once you differentiate it, you can create that one. Like you see, if I differentiate x squared, you can create 2x, then I immediately know that this is U substitution. So all I'm going to do is the item that I'm going to call my u, which with this one for U substitution for a fraction, that item is always at the denominator. I'll capture it, put in the position of f in that formula, then put its derivative at the numerator, then I'll do my adjustment. So let's go with our U substitution by using that formula on page 4 of Math N6 formula sheet. So this one, I capture it like that. So in this formula, the denominator we will put in the place of f in the formula. So in the place of f, I'm putting 16x squared plus 1. Then, according to what the formula wants, the derivative must be at the numerator. So if I differentiate 16x squared plus 1, it gives me 32x dx. So up to so far, what I have done here is what the formula wants. But I have to make sure that the two items are still the same. So I must compare what I've written here according to the formula to the original problem. So the original problem, you see there is a 4, there is an x, there is 16x squared plus 1, but this 32 does not appear in the original formula. So what I need to do is to look for a number that can take care of this 32 and write it outside. So that number can only be 1 on 32. So with this, I've done my U substitution already. So in my next step, I'm just writing down my final answer. So that's arctan x, arctan 4x minus 4 on 32. You see what we have outside is 4 on 32. Then the answer of this integral means the f that we place on the left must also go on the right of the formula. So whatever I called my f was 16x squared plus 1. So this is the limit of 16x squared plus 1 plus c. So for candidates who can understand how to apply this whenever they are sure they are dealing with U substitution for a fraction, it saves them a lot of time of doing all these things from here right down to the end. You see where we've ended is the same answer here, because 4 over 32 will simplify to the same 1 over 8. So that is it. So in our last problem, we are now going to try to only make use of that formula. We will not have to. Okay, guys, I was saying when we come to this one, this problem is basically like the first one, because when it comes to integration, I always tell students that whatever you do to tan, you do to cot. So whatever you've done to arctan is supposed to go to arccot. So I'm going to try also, we are going to try to handle this problem by using this formula, because we are very sure that this one will come across it, since it already happened with time. With integration, that is how they are related. Sine and cos are members of the same family, tan and cot are members of the same family. So I want to do this integral as a product. So already they've already put a constant there, and we all know that when we see a constant, our 4 should be seen as 4x to the power 0, so that we can put this under algebra. So that was a negative 4, so that will be our algebra. Then the other person will be inverse, and we know that with elate, as you can see, inverse comes before algebra. So we're going to say let our f of x be equal to arccot 1 over 4x. I prefer to call it 1 over 4x, so that my 1 over 4 should be in the position of a. Then what is the derivative? I will go to page 3 of my N6 formula sheet and see how to integrate arccot. So that will give me negative the derivative of this angle, which is 1 over 4 divided by f of x, the angle, all that square. So if you square 1 over 4, it gives you 1 over 16 you square x, you get x squared plus 1. So that is our derivative. Then if we take g prime to be equal to negative 4, this will mean that g, when you integrate, you get negative 4x. So we can now go to our integration. So if we get back to our integration, the integral of negative 4 multiplying up cot x over 4 dx will be equal to, we need our f and g according to the formula for integration by part. This is our f, that is our g. Multiply that, we get negative 4x up cot x over 4 minus the integral of f prime g. Now let's look at our f prime and our g. I always keep saying when I'm writing an integral, I practice putting the constant outside. So our f prime is negative 1 over 4 divided by 1 over 16 x squared plus 1. Our g, since this is a fraction, I'll try to write g as a fraction. I'll write negative 4x on 1. So if you are now multiplying them out, you will see that negative 4 and negative 1 over 4 will give me positive 1. So they will cancel one another. So the only constant going out is 1. Then we are left with x on 1 on 16 x squared plus 1 dx. So that is basically our problem. So from here, you can see that it is a fraction. And this fraction, when I differentiate x squared, you see with integration and differentiation, my target is the variable x. When I differentiate x squared, it will create x. So that immediately tells me that this is integration, this is u substitution. With u substitution, we must differentiate something to create the other one. And since it's a fraction, this our formula we've written up here is the formula for u substitution for a fraction. So u substitution for a fraction is very simple, because all you need to do is take the denominator, you put it in the position of f, then you differentiate and put up there, then you compare with the original complex. So I will simply do that. So this gives me negative 4x, the cot of x over 4 minus the integral of, so I will take the denominator, I'll put in the place of f in that formula. So as I put it there, I'll have 1 over 16 x squared plus 1. Then I will differentiate this and put my answer out there. When you differentiate this, you remember you are basically differentiating x squared, it will give you 2x times 1 over 16. So that will lead us to 2 over 16 x dx. Then, to make sure that my u substitution is complete, I will simply compare what I've done here according to what the formula wants to the original problem and see if they are still the same. So if I'm looking at them, I will see that this one is still outside, that x still exists, this denominator still exists, but 2 over 16 is a number that does not exist there. So all I need is a number that can take care of this 2 over 16. If I can write that number outside, then I'm done with u substitution. So a number that can take care of 2 over 16, what I mean by that is that 2 over 16, if I need to multiply it by something, it will give me 1. And that something can only be 16 over 2. So it means out here, I'm going to write 16 over 2. So if you succeed to do this, you are done with your u substitution. You can then write down your final answer, which is negative 4 up cot x over 4, then minus 8, 16 over 2 is 8, then your final answer says whatever you place on the left side of the formula, you will do it on the right side of the formula, which is just the limit of 1 on 16 x squared plus 1 plus c. So guys, this is how we integrate arctan and arc cot. Thank you very much.